The silence is the problem. Not the shaking. Not the tsunami. Not yet. Right now, in July of 2026, the problem is the silence itself. The Cascadia subduction zone, a 700-mile fault line running from northern Vancouver Island to Cape Mendocino in California, is producing almost no seismic activity, no small earthquakes, no tremors, no grinding of the plates that you would expect along one of the most dangerous tectonic boundaries on Earth. It is locked. It is quiet. And the last time it was this quiet, the year was 1700. To understand why silence on a fault line is terrifying rather than reassuring, you have to understand what a subduction zone actually is. The Cascadia Fault is the boundary where the Juan de Fuca plate, a remnant slab of oceanic crust, is diving beneath the North American continent. The oceanic plate is denser. It wants to sink. The continental plate is lighter. It resists. For centuries at a time, the two plates lock together along the fault interface. The oceanic plate continues to push eastward at roughly 40 millimeters per year, about the speed your fingernails grow. The continental plate does not slide smoothly over the top. It gets stuck. It bends backward, storing elastic energy like a compressed spring. Year after year, decade after decade, century after century, the strain builds, the silence deepens, and then one day, without warning, the lock breaks. The entire fault line unzips. In 1700, the unzipping produced an earthquake estimated at magnitude 9.0 or greater. The shaking lasted between 4 and 6 minutes. The coastline of what is now Washington, Oregon, and Northern California dropped by as much as 6 feet in an instant. Entire forests of ancient cedar and spruce were plunged below sea level, where their dead trunks still stand today. Ghost forests, visible at low tide, carbon dated precisely to the winter of 1700. A tsunami radiated outward across the Pacific Ocean. Roughly 9 hours later, it struck the coast of Japan with no warning, destroying fishing villages, killing thousands, and entering Japanese historical records as the Orphan Tsunami. A wave with no earthquake felt beforehand. No explanation available to the people who watched the sea rise and swallow their homes. The Japanese recorded the exact date, January 26, 1700. It took Western science until the 1980s to connect their records to the ghost forests of the Pacific Northwest. Until then, geologists believed Cascadia was a dormant fault, a harmless geological relic. They were wrong. It was not dormant. It was loading. The average interval between major Cascadia ruptures, calculated from 41 separate earthquake deposits identified in coastal sediment cores, is 240 years. Some gaps were shorter. Some were longer. The longest on record was roughly 500 years. But the median, the number that comes up again and again in the geological record, is 240. The last rupture was 326 years ago. That places the current moment not at the edge of the danger zone, but well past the statistical average for when the next earthquake should have already occurred. This is not a countdown. Geology does not work on a schedule. A fault does not owe anyone an earthquake on a specific date. What the overdue status means is that the strain accumulated since 1700 is already larger than the strain released in many previous ruptures. The spring is wound tighter than it was before at least half of the historical earthquakes this fault has produced. Every year of silence beyond this point loads additional energy into the system that will eventually be released. The physics of the release do not change. The longer the wait, the larger the stored energy. The larger the stored energy, the closer the next rupture comes to the maximum possible magnitude. What has scientists particularly focused on right now is not the historical math. It is the current behavior of the fault. In the past decade, researchers have deployed a network of GPS stations along the Pacific Northwest coast that measure the vertical and horizontal movement of the land surface with submillimeter precision. Those stations are showing something unmistakable. The edge of the North American continent is currently tilting upward. The land is bending. The locked zone of the Cascadia Fault extends from roughly 20 miles offshore to about 60 miles inland. East of that locked zone, the continent is being compressed and lifted. The GPS data confirms that the uplift is continuing and, in some locations, accelerating. The land surface of western Washington and Oregon is several inches higher today than it was when the measurements began. When the earthquake hits, every inch of that uplift will reverse in seconds. The coastline will drop. The 6-foot subsidence of 1700 will repeat. There is another signal, quieter than the GPS readings, that has researchers on edge. For years, scientists have detected what are called slow slip events along the Cascadia margin. Imperceptible movements of the deep fault interface that occur over weeks or months rather than seconds. These events are not earthquakes. No seismograph records them as a sharp jolt. They are more like the fault taking a shallow breath. They happen with surprising regularity, roughly every 14 months, deep beneath the Olympic Peninsula and Vancouver Island. In 2026, the most recent slow slip event began in late spring. It did something unusual. It did not stop where previous slow slip events had stopped. It propagated farther into the locked zone than any slow slip detected since monitoring began. Scientists are careful to say this does not mean the big earthquake is imminent. Slow slip events have been observed before and did not immediately precede a rupture. What it means, they say, is that the boundary between the freely slipping deep fault and the fully locked shallow fault is shifting. Stress is being redistributed. The part of the fault that has been silent since 1700 is feeling pressure it has not felt before. If that pressure reaches a critical threshold, the slow slip becomes a fast slip. The weeks-long event becomes a 6-minute event. The breath becomes a scream. When that happens, the consequences will unfold in a sequence that emergency planners have rehearsed for years, knowing the rehearsal is inadequate. The shaking will last 4 to 6 minutes across an area stretching from British Columbia to Northern California. Every unreinforced masonry building in the shaking zone will collapse. Bridges not retrofitted for a magnitude 9.0, and that is most of them, will drop. Highways, including Interstate 5, the single major north-south transportation corridor on the west coast, will fracture in multiple locations simultaneously. Liquefaction will turn saturated soils into quicksand beneath ports, airports, and downtown districts. Power will fail. Communications will fail. Hospitals built before modern seismic codes will become death traps instead of refuges. Then the ocean will arrive. The tsunami will reach the coast roughly 15 to 20 minutes after the shaking stops. The wave will not break like a surf wave. It will rise like a wall. Inundation maps show entire coastal communities, Seaside, Ocean Shores, Long Beach, Crescent City, submerged under 30 to 50 feet of water. The estimated death toll in FEMA planning scenarios is roughly 14,000 people from the earthquake and tsunami combined, with tens of thousands more injured and millions displaced. Those are the optimistic assumptions. They assume the event happens during the day, in good weather with functional warning systems. If it happens on a winter night in the rain, the numbers will be worse. If it happens during a king tide, the tsunami run-up will be higher. If it happens during a pandemic or after a major storm, the response capacity will be degraded. The scenarios compound quickly. The silence continues. The GPS stations keep recording. The slow slip event propagates deeper into the locked zone. The land tilts upward another millimeter. The spring compresses one more year. What happened in 1700 is not a mystery. It is a preview. The ghost forests stand along the coast like gravestones marking the last time the silence ended. They are not warnings from the distant past. They are messages from the most recent event in a cycle that has repeated 41 times. The 42nd is already loaded. When the silence breaks, it will break for everyone. Subscribe if you want to keep watching. We are watching the data. We will be here.